Okay, so for the first one there, 42 blank is 42% of 85. We start out with the 42% is 42 out of 100. What goes on the other side? 85 on the bottom. Perfect. Then we'll cross multiply and divide. 42 times 85 divided by 100 is, what's that? 38.25. Perfect. So 38.25 is 42% of 85. No? Well, let's see here. 42 times 85. 35.7. That looks a little bit better. Notice that's why it paused. So anyway, what was that? 37.5 or 38.5? 35.7. Okay. That's the joy of having the power over the controller. So anyway, 32 is 40% of blank. I should put the word of in there, might make it more clear. So 40 over 100, where does the 32 go? On top. Cross multiply and divide gives us 80. Perfect. 56 is blank percent of 70. So it's blank over 100. Which one goes on top and which one goes on bottom on the other side? 56 over 70. Perfect. Cross multiply and divide. 100 times 56 divided by 70 is 80. So 56 is 80% of 70. And blank is 130%. So 130 over 100 of 40. Where's the 40 go? Bottom. Cross multiply and divide. 52. Perfect. Any questions on any of those? Okay, good. Yeah. Very good question. Well, a lot of people do that. That's one shortcut that some people do teach. They teach is over of. That since the 56 is by the word is, it goes on top, and the 70 is by the word of, it goes on bottom. And these simple little sentence problems like this, that does work. 52 is with the is, it's on top. 40 is with the of, it's on bottom. But in some of your word problems, it doesn't necessarily work out that way, so you do have to be careful. But the key, if you get into word problems, is to match it up, like I've shown you. Let's do an example here. Let's say that, let's see here. Let's say feed costs are estimated as 35% of total production. Now by total production, I'm saying your total check, your total milk check. So how much was total production in a month where feed costs were estimated at $10,850. So here we have a percent, which is the 35%. So 35 over 100. So now remember, the percent itself always represents something, the 35, and the 100 also always represents something. The 100 always represents the main piece, the main object, and the 35 represents the piece that we're focusing in on. So usually the 35 is part of the 100. So whatever the 35 represents is part of the 100. So here the 35 represents what? feed costs are estimated as 35%. So the 35 represents the feed cost. The 100 is the total production. So on the other side, we have the 10,850, and trying to figure out where that goes, we can match it up. Does that represent the feed cost or the total production? Feed cost. Perfect. So that 10,850 has to go on top, and then we cross multiply and divide to find the total production on bottom. So 100 times 10,850 is 1,085,000. Divided by 35 is going to give us somebody help me out. Is that 31,000? So $31,000. Any questions? Now, we've mentioned a little bit about how you have to be careful that what you're finding is what you're actually looking for. Because we do run into problems like this where, let's say the price of a part goes up by, let's do this, goes up by 15% to $230. How much did it increase? How much in dollars, I should ask. What's the dollar amount that it increased? So we've got the 15% is 15 out of 100. What does the 15 represent here? Oh, it is the increase, right? That's how much it increased. The 100 represents, the original price, the price before the increase. So on the other side over here, do we have the dollar amount for either one of those values? No. The 230 is the price after the increase. So here we cannot use the 15%. What do? Yeah, it's an increase. So it's 100. The full thing plus 15 is going to give us 115%. Now here, the 115 is the price after the increase, and the 100 is still the price before. Do we have either of those amounts? Yes. The 230 is the price after the increase. Now this is going to give us the price before. Is that what we're looking for? No. Can it help us find what we're looking for? Yes, it will. So we cross multiply and divide. 100 times 230 divided by 115 is 200 bucks. What we want is the amount that it actually increased. How do we find it? Price after the increase minus the price before the increase is 30 bucks. That's the difference. Now, if you recall, I showed you briefly a little table that helps you deal with these. You can just do, I usually do before plus increase equals after. Again, the words you use in here don't matter. It's what they represent that matters. We have one side is percents, and the other side is going to be a number. In this case, it's dollars. We know that the after price in dollars was $230. We know that the increase was 15%. It looks like that's all of the information we have, but remember, we always have the 100. That's the before price. That's the starting amount, or initial amount. So from that, we can find, since it's plus an increase. 100 plus 15 is 115% represents the after. And what we're looking for here is the dollar amount of the increase. So this is what we're looking for. If you recall, we need 2 rows off this table. We need the row that has what we're looking for. In this case, that's the increase. And we need any row that has both numbers. That would be the after here. So we don't need that top row right now. We're not going to use it. So then we can cross multiply and divide right within the table. 100 times 230 divided by 115 would give us 30 bucks. To me, that table just helps keep it more organized for me. It avoids some mistakes. Similar to that, let's say for those of you in auto mechanics, usually if you set up shop, most of your part stores will give you a discount for being a business rather than just a consumer, just an owner. Like even here at WITC, you get a discount when you guys order parts through different shops. So let's say after an 8% discount, you pay, let's say $368 for parts. How much did you save? I'm going to give you guys about 2 minutes, see if you can figure that one out. We'll talk about it in just a couple minutes. So if I were going to list this one out, we have some sort of a full price minus a discount equals the amount paid. Again, whatever words you use to describe them are just fine. So on one side we have the percents, the other side is still dollars. What do we know here? We got the 8% discount, and yes, full price is going to be 100%. Is the amount paid going to be 108? 92, because the discount you would be subtracting. It's a reduction, a decrease. What else do we know? We had the $368. Good. $368 goes on the other side for the amount paid. Are we looking for the full price or the amount of the discount? How much did you save as the discount amount? So, well, we could find the full price, but we don't have to. We just write in here, do 8 times 368 divided by 92 ends up being 32 bucks. You could find the full price, which would be 400 bucks, then subtract to get it. That would work fine too. Okay, we talked about, notice everything we've done here, even the table is really the proportion method. You're still cross multiplying and dividing. You're matching up things that are related. We talked a little bit about that rate method. And that rate method is where you had to turn the percent into a decimal. And we mentioned that the rate method is really only horribly useful if we're doing a certain type of calculation, where we are going from having that whole amount, that 100%, and trying to find what that piece is that we're focusing in on. A great example of that is when we have like a commission. I think I spelled that right. If not, I apologize. There's a reason I'm a math teacher, not an English teacher. For commissions, and each of you may work on this at some point. For those of you in auto, if you get into the part sales or any sort of like a maintenance manager type position, you might work on a percentage of total business or total sales. In dairy, it's actually very common to pay as a percentage of the milk check. If you're paying commodities, there's a lot of different tax breaks that you get. So let's say that your commission is 2% of the total. whether you're working on a farm getting 2% of the total check for milk check for the month, or working in a shop and getting 2% of total service for the month. And let's say your total for the month is $189,000. We could do 2% as 2 out of 100, put 189,000 here and cross multiply and divide. And that would work, but doing that every month is kind of tedious. It's a little bit clumsy to set up. So what we can do is just take that total, 189,000 times, what's 2% as a decimal? 0.02. So now we just go ahead and multiply that out. 189,000 times 0.02 is going to be perfect, $3,780. So that would be your commission for that month. Now, because of for dairy farming, obviously that's relatively stable. Your milk check doesn't fluctuate tremendously. Milk prices do fluctuate tremendously, but you're guaranteed to have some production there, so you're going to have some sort of commission. Auto sales or whatever, or other sales types positions where you're working on commission, there might be months where you don't sell anything. So it's possible to end up with no commission. Most states have cracked down on this now, where they don't allow you to just work on straight commission anymore. They have to do something to guarantee that you're going to make at least a minimum wage for the hours you put in. So that's why many places that do sales commissions have gone to a wage plus or a salary plus type system. So let's say that you are working as a parts manager at a major shop, and you do work on a commission of what's coming as parts. So let's say you're working on $12 per hour plus 4% of sales. So you have a week where you work 38 hours. I'm keeping it under 40 purposely so we don't have to deal with time and a half and stuff like that. And your sales of parts is $28,000. So your pay for that month, well, 38 hours times $12 per hour is going to give us what? $456. And then our 28,000 times what? 4% becomes what is a rate? Is a decimal? 0.04, good. That's going to be what, 112? Or 1,120. Is that right? 1,120? So that adds up to $1,576 for the month, for the week. Any questions? There's a lot more I could do on commission, but I'm not going to get into it. I want to talk a little bit now about one of the other big applications of the rate method, and that is interest. Interest, and we're going to start out talking about simple interest for today. Simple interest is just that. It's the simplest way you can calculate interest. In simple interest, interest is only calculated on one of two conditions. The end of a term, so at the end of the investment or the end of the loan, or when there's an action on the loan. we'll say an action on the account. So if you have a savings account that is simple interest, every time you made a deposit into that account, they would figure out the interest before they made the deposit. Or if you made a withdrawal from the account, they would figure out the interest before you made the withdrawal. So let's take a look at an example here. The amount of interest, the dollar amount of interest is I equals P, which stands for principal, times R, which stands for rate. That again is just your percent as a decimal, times T, which is time. Time is always represented in years. So let's say you invest $4,000 at 8% simple interest. For 3 years. The amount of interest is just going to be I equals, what's our principal? 4,000, yep. What's our rate? 8%. So I'm going to write that as 0.08. Perfect. And our time is 3 years. So I'm going to write that as 3. It's 3 years. So if I multiply that out, 4,000 times 0.08 times 3 is what, $960? So what that means is your balance at the end which is the technical term for it is maturity value, is equal to your principal plus that amount of interest. So that'd be $4,000 plus the $960 interest. So you end up with $4,960. Most banks are not going to go for an investment where money sits there for 3 years and interest isn't calculated until the end of the 3 years. They don't like that. Usually they only use simple interest on things that are going to have interest calculated on a regular basis or very, very short term. For example, this is something I used to have to do all the time. Up until about 2 years ago, I ran a construction company in the summers. Every now and then you'd get to a point where it's time for payroll. You need to pay your employees and you haven't finished a job, so you haven't got paid yet. So I would go to a bank and so I'm going to borrow $8,000 to cover payroll. They might say they're going to charge me 9%. And let's say they're going to do it for 4 months. I need to figure out how much I'm going to have to pay back at the end of that 4 months. So I start by finding the amount of interest. What's the principal here? 8,000. What's the rate? 9%. So I'm going to write it as 0.09. Now here's the tricky part. We said the time was always given in years, but this says 4 months. So we would write that as 4 over 12. So now what's that come out to be? $24? Does that look right? Or $240? What's that? Oh, let's give it a shot. 8,000 times 0.09 times 4 divided by 12. I get 240. You might have put the 4 divided by 12 and then typed it back in. or did a 0.333 as a decimal or something, we give you that little bit of a round off here. So there's $240 in interest. So that means I have to pay back $8,000 plus $240. So $8,240 is what I would have to pay back. Now there might be some things out there that are calculated in simple interest that might surprise you. Like I said, like I showed here, they typically only want to do, banks only want to do simple interest if it's a very short-term loan, or if it's something where they're going to have some sort of an action on the account on a regular basis so they can figure in the interest. Two types of loans that are actually simple interest that most people don't expect. Car loans are usually simple interest. And home mortgages are simple interest. But I think, well, home mortgage, that's like 15 to 30 years. Why would they do simple interest on that? Well, on a mortgage or on a car loan for that matter, what are they expecting you to do every month? Make a payment, right? That's an action on the loan. So when you make a payment, before they accept the payment, they figure out the interest, add the interest in, and then they make your payment, take out your payment. So those types of loans actually are simple interest because of that. Tomorrow we will talk about compound interest and some investment stuff. There will be a quiz tomorrow on percents. We won't have the interest and commission stuff on there yet tomorrow, but we will have a quiz on regular percents tomorrow. Thursday then will be our Unit 1 test. Tomorrow the investment talk will end our Unit 1, and we will be ready for our test on Thursday. For now, in your book, on page 97, problems 1 through 13 talk about interest. Only do the ones that are simple interest. The rest of them that are compound interest and annuities, we will talk about more tomorrow. So I'll let you guys have the last 14 minutes here to get started on those.